Alright, welcome back to an exciting lesson in Algebra 2. We have previously talked about how to find inverses. Now we are going to talk about how to verify if we have done it correctly, or if you are given two functions, how to determine if they are inverses of each other. So first of all, we are going to recap what it means to evaluate a function. So if f of x is equal to 3x plus 5, and you're being asked to evaluate f of 5, that means you are substituting or evaluating when x is 5. So you are going to substitute a 5 everywhere that you have an x, and then use your order of operations to move forward. So first you would do multiplication. 3 times 5 is 15. Then you would add the 5, and finally you get 20. So that means f of 5 is 20. Similarly over here, g of x is equal to x minus 5 over 3. If I want to find g of 17, that means I'm going to substitute 17 everywhere that I have an x, and then use my order of operations to continue. 17 minus 5 on top, that's in parentheses, and that is 12, and 12 divided by 3 is 4, so that means g of 17 equals 4. So you're evaluating a function, you're plugging in a number for x. We can actually do something called composition of functions, which is where we plug one function into another. And so this is what that notation looks like. You might also see like f of g of x, that open circle, or the other way around. And so that's how we read it, f of g of x, or in this case, g of f of x. So you're going to take your two functions, and whichever one is on the inside, you are going to substitute that entire function into x in your other. So I'm going to replace x with 2x plus 3. So that will be 2x plus 3 over 2. And again, just use your order of operations to move forward and simplify. In my numerator, I've got 3 plus 3, which is 6. So 2x plus 6 over 2. Both the 2x and the 6 are divisible by 2, so I can simplify this to x plus 3. And so when you are doing composition with functions, your end result will still have a variable in it. Unlike what we did at the top where we were plugging in a number and our answer gave us a number, when we were plugging in functions, your outcome will be another function, something with x. Okay, now let's do this the other way around. G of f of x, which you could also see written in this notation. They mean the same thing. So now we are going to plug f, this entire thing, x plus 3 over 2, in place of x here. So that will be 2 times, I've got x plus 3 over 2 plus 3. So I'm going to use my order of operations to simplify this. These 2's divide down to 1. So I've got x plus 3 for a final result of x plus 6. So that is composition, plugging one function into another, and your outcome should be another function. Now, why is that helpful? Why do we want to know that? Well, to verify if functions are inverses of each other, we do composition, and your end result should be x by itself. If you do composition both ways and you get x by itself, that means the functions are inverses of each other. So let's look at these two functions and see if they are inverses. First, we're going to take f of g of x, which means we are going to plug this entire thing, x minus 5 over 3, in place of the x here. So that will be 3 times x minus 5 over 3 plus 5. I'm going to use my order of operations. The 3's divide down to 1, and I've got x minus 5 plus 5. Well, negative 5 plus 5 is 0, and so I am just left with x, which is what we were hoping for, but I'm not done yet. I still have to do my composition the other way around to verify it. So now we're going to do g of f of x, which means I'm going to plug in x minus 5 over 3 in place of the 3 here. Sorry, other way around. I'm going to place 3x plus 5 in the x here. We already did the other thing the first time. So I'm going to place 3x plus 5 into the x here. So that will be 3x plus 5 minus 5 over 3. Order of operations, I can do this subtraction on the top. 5 minus 5 is 0. So that gives me 3x divided by 3. Well, 3 divided by 3 is 1. So that just leaves me with x. So the composition did work both ways. Therefore, f and g are inverses of each other. So we are going to end this out by first finding the inverse of h, and then we are going to verify our answer using composition. So quick refresh from last time. I'm going to rewrite this in y equals notation. Then I'm going to switch the x and the y. So x equals negative 3y plus 6 over 4. And now we are going to use algebra and order of operations to get y by itself again. So first I'm going to multiply both sides by 4 to get rid of my denominator. Then I'm going to subtract 6. So now I've got 4x minus 6 equals negative 3y. And then I can divide everything by negative 3. So y equals 4x minus 6 divided by negative 3. So that means h to the negative 1 of x, which is our inverse, is 4x minus 6 divided by negative 3. Now I'm going to do composition both ways to verify that these are inverses of each other. So first I'll do h of h to the negative 1 of x, which means I'm going to plug this whole thing into our x here. So negative 3 times 4x minus 6 over negative 3 plus 6 divided by 4. Negative 3 divided by negative 3 becomes 1. So I've now got 4x minus 6 plus 6 in my numerator over 4. Negative 6 and 6 adds to 0. So I've got 4x divided by 4, which does divide down to just x. So it works the first way. Now I have to do it the other way around. So now to make absolutely sure that we have done this correctly, we are now going to take h to the negative 1 of h of x, which means I'm going to plug in my original function in place of x in my inverse. So that's going to be 4 times negative 3x plus 6 divided by 4 minus 6 divided by negative 3. So the 4 and the 4 divide out to 1, so I've got negative 3x plus 6 minus 6 divided by negative 3. Well, 6 minus 6 is 0. So now I have negative 3x divided by negative 3. Negative 3 divided by negative 3 divides down to 1. And so I got x again both ways. And that is how you verify your inverses using composition. Remember, composition is just substituting a function into another.